In this episode, we will provide a brief introduction to the interchange module, mainly about the automatic alignment design function, and some basic horizontal alignment design methods for interchanges. Before we move on to the interchange design tutorial, I will introduce the alignment design method of EICAD. We name it as mode method. The basic logic is, the alignment design can be deconstructed as the connection between straight lines and circular curves. In some cases, especially for interchange design, clotoid curves are used to connect lines and circular curves, or two circular curves. The mode method can automatically calculate the alignment design outcome by the line and arc, or circle elements. Compared to the create route command, the mode method is more commonly used to design complex alignments, such as interchanges and mountain roads. EICAD has two basic modes. The first basic mode is the line circle mode. As the name of this command suggests, draw a line element and a circle element. Click the line circle mode and select the line and circle elements, and you can see the basic mode editing window. Here, you can move the line and circle to adjust the shape of the alignment. On the right side of the window, you can edit the parameters of the clotoid curve, and you can select Move Circle or Move Line when you change the parameters. The second basic mode is Circle Circle mode, which can generate the alignment with two circle elements. Same with the Line Circle mode. You can move the circle elements and set the parameters of clotoid curves. But with Circle Circle mode, you can set the curve shape as an S shape or a C shape, depending on the design requirements. The extended modes are the combination of two basic modes. For example, the line circle circle mode is the combination of a line circle mode and a circle circle mode. There are many other extended modes under this module. I will not introduce these modes one by one in this tutorial. All of them are combinations of two basic modes. To design an interchange, firstly, we need to design the main route alignment on the terrain entity. Double-clicking the route entity or label, entering the route name, class, design speed, and relating the main route with the terrain entity. Then, we will use the Automatic Alignment Design function, under the Interchange module, to quickly design an interchange. This function supports the three most commonly used interchange formats. We will use the trumpet interchange as an example. The trumpet interchanges usually contain a ramp, cross, or under the main route. We refer to this ramp as ramp C. Two ramps connect the end of ramp C and the main route. We name them ramp A and ramp B. And the rest two ramps we name as ramp D and ramp E. The name of each ramp can be different, depending on different standards, but we will name them as ramp A, B, C, D, and E in this tutorial, for easy memorization. Now, we need to draw a line as ramp C. Then click the trumpet interchange under Automatic Alignment Design. We need to follow the command introduction. Select the main route alignment first. Select the intersecting ramp, which means the ramp C. Then, pick the approximate start location of the circular ramp. Select the DE ramp divergence entity, which is ramp C again, but on the opposite side of the route. After selecting all elements of the interchange, the automatic design window will pop up. Here, you can set different parameters of the interchange, such as head radius, the minimum circular ramp radius, and many others. Click the Draw Refresh button to preview the design result. You can click the hand icon in the bottom right corner to hide the window. And press ESC to show the window again. If you are satisfied with the design result, click OK to finish. Now, you may have noticed that the color of the alignment is the same as the root entity. but it is not a root entity. You can select and edit different alignment elements separately. For example, if the line element is too short, we can use the extend line or arc function, or enter the shortcut command LD. Select the element that needs to be extended, and move your mouse to change the length. If you are not satisfied with ramp E alignments, you can delete the clotoid curve between two circular curves and use the circle-circle mode to regenerate the clotoid curves. You can set the clotoid curve length and A values. The system can calculate and draw the new alignment automatically. You can use the mode method to adjust all the ramp alignments until you are satisfied. When all the alignments are defined, we need to generate root entities from the alignments. Use the search and convert root command under the alignment module, or enter the shortcut command SS, and select the alignment to transfer it into a root entity. The system will prompt you to delete the original elements. Click Yes. The alignment elements will be deleted, and the root entity will be kept. Click No. The alignment geometries will be kept. Repeat the search and convert command. Convert all the curve elements into ramps. Now we need to name each root, set the root class as ramp, set the design speed, and relate the alignment with the terrain. The relevant operations are introduced in the alignment episode. Then, we need to check whether the stations of these routes are correct or not. Please note that in this tutorial, the default traffic is right-hand traffic. The ramp driving direction may be different from your traffic standards. We can check the driving direction by the station number. For example, ramp E station number sequence is reversed. Select the route, right-click to open the menu and click Reverse Route to flip the station number sequence. Now, we have finished the interchange alignment design. Then, as we discussed in the cross-section episode, create the roadbed template for each alignment. For the main road and ramps A, B, D, and E, the system will read the road class and design speed, and generate the default roadbed template of different standards. Please note, ramp C is special. You need to switch the lane type to 4, bidirectional dual lane, and click OK to create the correct roadbed template. After completing the creation of cross-sections, EICAD can automatically read these roadbed templates and generate all route offset curves and markings. Select the Drawing, Draw Interchange Offset Curves command under the Interchange module, and the system will open the Draw Interchanges Offset Curves window. It will read all alignments and their roadbed templates from the current drawing. Please note, the name of the roadbed templates must be the same as the route name, so the system can match each alignment and roadbed template. In this window, you can set parameters such as the gradient segment length, fillet radius of the soft shoulder, draw markings or not, and label settings. Click OK to generate offset curves and road markings. Now, we have finished the automated interchange alignment design and road markings, and the system has labeled the location of each nose end, the acceleration lane, and other gradient segment lanes. You can continue creating profiles, vertical curves, super elevations, slope templates, and other components of the interchange, and assemble them into the interchange model. All the operations are introduced in other sections of this tutorial. In this episode, we have discussed the automated design of interchange alignments, offset curves, and road markings. The next one will be the last episode of the beginner tutorial, the drawing output module.